Hi there. In this presentation, we're going to discuss the mean value theorem as a continuation of what is known as the Roy's theorem. Now, before we engage on the statement in the conclusion of the theorem, I would like to first of all look at the following short clip, which I showed you also in the previous presentation on Roy's theorem. Okay, let's see. Okay, guys, for now, let's occupy ourselves with the mean value theorem. First of all, I would like to invite you to understanding the word mean as average. That word there, let's interpret it as average. Why average? Let's say we've got this this curve here, and we've got the second line which cuts the curve there and there. Now, if we are aware of the fact that the slope of the curve at each and every point here changes, but if we want the average slope between these 2 points, we would have to take, let's say the point here on the x-axis is B and there is A. So to get the average slope of the curve between these 2 points, we would say f at B minus f at A over B minus A. I think that's, you should notice that as a formula for calculating the gradient of a line, because the gradient of a curve, like gradient of a curve there, is given by the gradient of the tangent line. So now the average gradient between 2 points like this is given by the gradient of the second line. Now, what does the mean value theorem says? It says that we've got a function f of x which is continuous and differentiable. Remember what we said about differentiable, as a tangent or a gradient defined between the points A and B. So the theorem says if the function is defined between A and B and is continuous and is differentiable, then there exists a C between A and B such that f prime at C is equal to f at B minus f at A over B minus A, meaning the gradient at that point C will be parallel to the second line. That's what the theorem says. Now, the gradient at that point C between A and B will be equal to the average slope between the point A and the B. I think at this point we are ready to engage the theorem and try to understand the statement of the theorem and as well as the proof. For now, let's move on to discuss the mean value theorem, which in common man's language would say the average value theorem. Now, turning to the mean value theorem, let's recap what Roy's theorem said. We suppose we've got a function, like we've got a function which is continuous and differentiable at every point. So what the Roy's theorem stated is that if a function is continuous, let's say between 2 points A and B, then what happens that if the f of A is equals to f of B, which actually means that the points A, f of A and B, f of B lie on a horizontal line. A situation which we can present this way. Let's say we've got A here and we've got B there. Then the point here is B, f of B, and here is A, f of A. So Roy's theorem says if this is the situation, then between A and B there exists at least one value C which belongs to the interval A, B, such that f prime at C is equals to 0, which we can illustrate by saying what this means, that between these 2 points there's a point C in this open interval such that the gradient of that or the gradient of the tangent line at that point C is equal to 0, meaning that the tangent line is horizontal, which means we can do something like this. Then having the tangent point there, then the C we're talking about will be vertically below this point, and it will satisfy this condition. Now, this is actually a very particular case of what we call the mean value theorem. In this case, it's when we've got f of A equals to f of B. Then between these 2 points, when the curve is continuous, we're guaranteed to have a C where the tangent is horizontal. Now, turning to the Roy's theorem, this is a different case. Let's say we've got A and a B there. Likewise, we're going to have here B, comma, f of B, a point on the curve, and there we're going to have A, comma, f of A, also a point on the curve of the function y is equals to f of x. Now, what I would like you to understand very well is also the name of the theorem. It says mean. And before I've advised you that to interpret this mean as meaning average. So this second line, which we have got here, the second line, we can clearly see that its gradient is given by f of B minus f of A over B minus A. Let's call that M sec for gradient of the second line. Now, what this can be interpreted be, this gradient can be interpreted as the average slope of the curve y is equal to f of x between the points A and B. That's why the theorem is called the mean value theorem. Repeating, this can be interpreted as the average gradient of the curve between points A and B, because we know that the gradient of this curve, as we've seen before, of the curve actually changes from point to point between A and B, and hence this is the average. Now, the mean value theorem now says if we got such a situation, then there exists a point C, again in the open interval A, comma B, such that f prime, in other words, the gradient of the tangent line at point C is equal to the average slope between A and B, average slope of the function f of x. So f prime at C is going to be equal to f at B minus f at A over B minus A. So in simple words, this theorem states that if we've got a second line between 2 points, which only 2 points on the curve, and the curve within that interval from A to B is continuous and differentiable, then there will be always a point C between the points A and B where the tangent line has got a slope which is equal to the average slope between the 2 points. That's what the mean value theorem means. Now we can read again the statement of the theorem in your text and try to apply it to do examples to try to further understand the theorem and be able to apply it in solving problems. For now, I would like to say thank you for listening.